Hi guys, welcome back to another video of Codehal. In this video, we will learn step by step how to create an amazing 3D animation website on scroll using HTML, CSS, and JavaScript. Here, on this website page, you can see a bee flying smoothly. As I scroll the page, the bee will gradually change its position smoothly and in real time, following the scroll movement with position adjustments and camera angles in each section. As the scrolling continues, the bee keeps moving dynamically, filling the empty space with smooth transitions. When I scroll again to the next section, the bee naturally adjusts its position and camera angle. After that, when I scroll back up, the bee will smoothly readjust its position in each section. Alright, let's start creating the 3D animation website on scroll using HTML, CSS, and JavaScript with simple code that is easy to understand and can also be followed by beginners. But before continuing, don't forget to press the like button and subscribe to Codehal so you don't miss other exciting tutorials about programming and web development. Don't skip this video to make sure you don't miss any steps. And now, let's get started. Alright, this is the HTML file that I have prepared with a basic HTML structure. I have also added a link tag to connect this HTML file with the style.css file. Then, this is the CSS file. In this video, I will only focus on displaying a 3D model and then creating an animation for the 3D model when we scroll the page using JavaScript. If you want to use this initial setup, I have provided a download link in the video description. You can download it and follow the steps in this video directly. Now, we will run this project using the Live Server extension in Visual Studio Code. With Live Server, we can see changes directly in the browser without having to refresh the page manually. At this point, on this page, I have already created a navbar and 4 sections: Home, About, Gallery, and Contact. Next, we will look for a 3D model to use on our website page. For that, we can visit the Sketchfab site and search for a 3D model that suits our needs. In this example, I will search for a bee model. And I choose this bee model. After finding the desired model, click Download 3D Model. And choose the GLB format because this format is lighter, compatible with the technology we will use, and works well for displaying 3D models on a website. You can download the model in this format. Once the 3D model is successfully downloaded, move the file into our project folder. The next step is to display this 3D model on the website page. Since HTML does not have a built-in tag for displaying 3D models in GLB format, we will use Model Viewer. Now, we can visit the Model Viewer site. With Model Viewer, we can easily display and control 3D models on a web page without complicated setup. To use it, we need to add this script to our project. Copy this. And paste it here before the closing body tag. This script allows us to use the Model Viewer tag in HTML. Now, we can display the bee model that we downloaded by adding the Model Viewer tag, which functions similarly to the IMG tag. Next, add the src attribute. Then enter the 3D model file name along with its format. And here, we will also add an ID named bee model. After adding this line of code, the bee model is now successfully displayed on the website page. Next, we will adjust its size to make it appear larger and keep its position fixed so that the bee model follows movement when we scroll the page. For that, we will add styling using CSS. We can copy the ID name from this element. And we will add the following properties. Position fixed to ensure the model stays in place when the page is scrolled. Width 100% and height 100% to make sure the model's display area covers the entire screen, making the B model look bigger and clearer. Pointer events none so that the model does not interfere with interactions with other elements on the page. Z-index 100 to ensure the model is above other elements. And transition to provide a smooth transition effect when the model's position changes. However, this effect is not visible yet because the transform has not been applied. Later, when we change the transform through JavaScript, this transition will work. After adding all these properties, the B model now looks larger than before. Additionally, when we scroll the page, the model stays in its position because we have set the position fixed property on this model. Next, we will start writing JavaScript code to animate this model so that it moves positions and adjusts the camera when we scroll the page. To start, we will first create a JavaScript file. Click New File and name it script.js. After that, make sure to link this file with our HTML file. Right here. And enter our JavaScript file name. Once connected, now we can start writing JavaScript code here. We will start by defining a variable named bModel. This variable is used to store the element with the ID bModel, which is retrieved using the getElementById method. Next, we will define the variable sections. This variable is used to store all section elements in the form of an array. We use the querySelectorAll method to retrieve all section elements in the HTML, then convert them into an array using array.from so we can easily access and manipulate them. Then, we will define the variable section offsets. This variable is used to store the offset values of each section, which is their relative position to the top of the page. Here, we use the map method on the sections array to create a new array containing the offset top values of each section element. So, if we check in the console now, it will display an array containing 4 offset values in pixels for each section. The offset top value represents the distance of the top edge of each section element from the top of the page. We will use this value to calculate scroll progress. Next, we will define the variable last section index. This variable is used to store the last index of the sections array. The value sections.length represents the total number of sections, which is 4, then we subtract 1. Since array indexing starts from 0, if there are 4 sections, the last index is 3. This variable is useful for determining the endpoint when calculating scroll progress. Next, we will define a function named getScrollProgress. This function is used to calculate the scroll progress based on our position within the page. This function receives a parameter called scrollY. This parameter is used to store the current vertical scroll position value, so the function can determine the section of the page that is currently visible and calculate the scroll progress based on that value. Inside the function, we use a for loop to go through each index of the page sections. The loop starts at index 0 and continues as long as the index is less than the last index, which is 3. In each iteration, the index value increases by 1, moving to the next section in the list. Then, inside the loop, we use an if condition to check whether scrollY is between the 2 offset boundaries of the page sections, meaning the starting boundary of the current section and the starting boundary of the next section. If scrollY falls within this range, it means we are in that section. I give an example in this image to clarify the meaning of this code. You can pause this video to make it easier to understand. Easy, right? Alright, let's continue. If the condition in the if statement is met, we return the interpolated value between 2 sections. This calculates scroll progress as a decimal number between 2 sections. Let's discuss this code one by one so that it is easier to understand. First, this code is used to calculate how far we have scrolled within the current section. The way to do this is by subtracting the current scroll position with the starting boundary of the current section. Then, this code is used to calculate the height of the section, which is the distance from the start of the current section to the start of the next section. The way to do this is by subtracting the starting boundary of the next section with the starting boundary of the current section. Then, we divide both numbers. This results in a value ranging from 0 to nearly 1, which indicates the percentage of scroll progress within the current section. Finally, we add the result of this division to the current index. This way, the final result is a decimal number that indicates the progress of the transition from one section to the next section. For more clarity, you can also look at the calculation example in this image. Easy, right? Then, if no if conditions are met in the loop, we return last section index. This means we have reached the last section of the page. Next, we will add an event listener to detect scroll movements on the page. This event listener will execute a callback function every time we scroll the page. Inside the callback function, first, we will define a variable named scrollProgress. This variable is used to store the scroll progress value returned by the getScrollProgress function. Here, we call the getScrollProgress function, passing scrollY as an argument. The scrollY property is a value that indicates the vertical scroll position in pixels, or simply put, scrollY is the value that shows how far the page has been scrolled. This is how it works, so, when we scroll the page, the getScrollProgress function is called and receives the scroll value as an argument. This value is then passed to the function parameter, scrollY, and processed according to the logic we have created. After processing is complete, the function returns its result, which is this value or this value. And the value returned by this function will be stored in the scrollProgress variable. Now, if we check scroll progress in the console, we will see a decimal number that dynamically changes as we scroll the page. These values result from the calculations returned by the getScrollProgress function. Next, we will determine the current section index based on the obtained scroll progress. The math.floor method is used to round down the scroll progress value to the nearest integer so that we get the integer index of the currently active section. Now we will check the result of section index. As we scroll, the section index value displayed in the console is a whole number indicating which section of the page we are in. This value is useful for identifying the currently active section. Then, we will calculate the progress within the active section by calculating the difference between scroll progress and section index. So, this section progress variable is used to store the difference between scroll progress and section index. The way to do this is by subtracting scroll progress with section index. The result is a decimal value that indicates how far we have scrolled within the current section. This value always ranges from 0 to nearly 1. So, this calculation is used to determine progress within a single page section. And now, we will check the result of section progress. As we scroll within a section, its value changes from 0 to nearly 1. This value is useful for controlling animations within the current section. Then, when moving to the next section, the value resets from 0 to nearly 1 again. This allows us to define different animations for each section with smooth transitions. In simple terms, the animation on the 3D model element will continuously adjust to the latest changes in the current section, ensuring smooth transitions throughout the page. Next, we will define a function named interpolate. This function is used to calculate the interpolation value between start and end based on the progress value. This function receives three parameters: start, end, and progress. The start parameter is the initial value before the change occurs, end is the final value that becomes the interpolation target after the change occurs, and progress is a value in the range of 0 to nearly 1 that controls the gradual change from start to end. Inside the function, we return the interpolation value with a formula like this. Let's discuss one by one. First, we calculate the difference between the end and start values. Then, multiply this difference by progress to obtain the change that corresponds to the scroll progress. And finally, add the start value so that the interpolation result always remains within the range from start to end. So, this function is useful for creating smooth transitions on our 3D model element based on scroll progress. Later, I will provide another calculation example in the image after I finish writing the code for the B model position transition so that it is easier for you to understand. Next, we will define the variable shift positions. This variable is used to store a list of horizontal shift values that will be applied to our 3D model element. Each number in this array represents how far the 3D element will shift in each section. Here, we input 4 values. The first value is 0, meaning the B model will be centered in the home section. Then -20, the model will shift to the left in the about section. 0, back to the center in the gallery section. And 25, the model will shift to the right in the contact section. And now, we will define the variable current shift. This variable is used to store the value returned by the interpolate function. Here, we call the interpolate function. This function receives 3 arguments, namely 2 values from shift positions, the current position value and the next position value, as well as the section progress value. So, this function will calculate the interpolation value between the 2 positions based on section progress. Then, this nullish coalescing operator is used to handle the possibility of null or undefined values, so if the next position value does not exist, for example, it has reached the last section, it will still use the current position value as the default. Finally, we will apply this current shift value to our 3D model element, namely B model. We use the transform property with translate x so that B model can gradually move left or right based on the current shift value. And we provide this value in percentage units. Before we see the result, as I mentioned earlier, now I will provide an example calculation of the B model position shift produced by the interpolate function in the following image. Easy, right? Now, let's see the result on our website page. As we scroll down the page, its position will gradually change following the values determined in the shift positions array. And this shift occurs smoothly thanks to the interpolation function in our JavaScript code and the transition property we applied to the B model element in CSS. Likewise, when we scroll up, the B model will dynamically adjust its position according to the scroll progress, creating a very smooth animation. Next, we will adjust the camera position relative to this B model so that it can change in real time, dynamically, and smoothly in each section as we scroll through the page. To change the camera position relative to the 3D model, we will use the camera orbit attribute provided by Model Viewer. This attribute accepts 2 values. The first value determines the rotation on the horizontal axis, while the second value determines the rotation on the vertical axis. Both are expressed in degrees. So, currently, the B model is viewed from above, but I want to change the camera position so that it appears from the left side. To do that, I will set the horizontal rotation to 90 degrees and the vertical rotation to 90 degrees as well. These 2 values will be the default position when the website page is first loaded. Now, the B model is completely visible from the left side. Next, let's continue writing JavaScript code so that the camera position relative to the B model can change dynamically in each section. First, we will define a variable named camera orbits. This variable is used to store several pairs of values that represent the camera's orbit angles. Each pair contains two values. The first value for the horizontal angle and the second value for the vertical angle. So, for the Home section, the B model will look like this. For the About section, the model will look like this. Then for the Gallery section, the model will look like this. And finally, for the Contact section, the model will look like this. And now, we will define the variable current orbit. This variable is used to store the value returned by the interpolate function as the result of interpolation, which is then stored in a new array. Here, we use the map method on the current camera orbit to create a new array that contains the interpolation result for each orbit value. The map method will iterate over each element in the array, then for each element, map will execute a callback function. This callback function receives two parameters. The first parameter is val, which is the value of each current camera orbit. Then the second parameter is I, which is the index of the element in the array. And inside this callback function, we call the interpolate function to calculate a new value based on the scroll progress. This function receives three arguments: the current camera orbit value, the next camera orbit value that will be the interpolation target, and the section progress value, which indicates how far we have moved to the next section. So, this function will calculate the interpolation value between the two orbits based on section progress. And here, we use the optional chaining operator to avoid errors if the next index exceeds the length of the camera orbits array. So, if the next camera orbit value exists, then we take the next camera orbit value that corresponds to the index of the array. If it does not exist, for example, if we have reached the last section, then we use the current value as a fallback using the nullish coalescing operator. So, in other words, if we are already in the last section, we still use the last value to prevent errors or interpolation to an undefined value. Alright, after we get the current orbit value, we will use it to set the camera orbit attribute on the B model element. Here we use the setAttribute method to change the camera orbit attribute with the value obtained from current orbit. The value at index 0 is the first value in the current orbit array, which represents the camera orbit at the horizontal angle. Meanwhile, the value at index 1, which is the second value, represents the camera orbit at the vertical angle. And both are expressed in degrees. Before we look at the result, I will also provide an example calculation of the camera position change on the B model produced by the interpolate function in the following image. Easy, right? Now, we will see how the camera moves as we scroll on our website page. You can see that as we start scrolling, the camera moves from one position to another based on the values we have set in the camera orbits array. This camera movement does not happen suddenly but uses interpolation to create a smoother transition when moving through each section of the website page. Likewise, when we scroll up, the camera will dynamically adjust its position according to the scroll progress. And finally, to make our website page more interesting, we will enable the flying animation on this B model. So, here we just need to add the autoplay attribute provided by Model Viewer so that the animation runs automatically. Now, you can see that the B model appears to fly naturally while adjusting the camera position and orbit in each section of the website page. At the end, we have successfully completed the creation of 3D animation website on Scroll using HTML, CSS, and JavaScript. I hope this video can provide insight and benefits for you. If there are any questions or anything unclear, do not hesitate to leave a comment below. Don't forget to like this video, share it with your friends, and subscribe to the Codehal channel so you don't miss various other interesting tutorials about coding and web development. Thank you very much for taking the time to watch this video. See you in the next video.